The periodic table, also known as the periodic table of elements, is a tabular display of the chemical elements, which are arranged by atomic number, electron configuration, and recurring chemical properties. The structure of the table shows periodic trends. The periodic table of elements arranges all of the known chemical elements in an informative array. Elements are arranged from left to right and go top to bottom in order of increasing atomic number. Order generally coincides with increasing atomic mass. The rows are called periods. Speaking of elements, I drive one! Number 1. The alkali metals. The alkali metals are recognized as a group of family of elements. These elements are metals. Sodium and potassium are examples of elements in this family. Hydrogen is not considered an alkali metal because the gas does not exhibit the typical properties of the group. However, under the right conditions, temperature, and pressure, hydrogen can be an alkali metal. Alkali metals have one valence electron, are typically soft metallic solids, shiny and lustrous. They have high thermal and electrical conductivity. Low densities, increasing with atomic mass. Relatively low melting points, decreasing with atomic mass. Vigorous exothermic reaction with water to produce hydrogen gas and an alkali metal hydroxide solution. They ionize to lose their electron, so the iron has a +1 charge. 2. The alkali earth metals. The alkaline earth metals, or simply alkaline earths, are recognized as an important group and family of elements. These elements are metals, and examples include calcium and magnesium. The alkaline earth metals, alkaline earths, have 2 valence electrons, are metallic solids harder than the alkali metals. They're shiny, lustrous, and oxidize easily. They have high thermal and electrical conductivity, are more dense than the alkali metals, higher melting points than alkali metals, exothermic reaction with water, increasing as you move down the group. Beryllium does not react with water. Magnesium reacts only with steam. Oh, really? That's pretty cool. And they ionize to lose their valence electrons, so the ion has a +2 charge. 3. Transitone group. The largest family of elements consists of transition metals. The center of the periodic table contains the transition metals, plus the 2 rows below the body of the table. Lanthanides and actinides are special transition metals. They are typically hard metallic solids and are shiny and lustrous. High thermal and electrical conductivity. They're dense, have high melting points. 4. Boron group. The boron group, or earth metal family, is not as well known as some of the other element families. Boron group, or earth metals, have 3 valence electrons, diverse properties, intermediate between those of metals and nonmetals. The best known member of this family is aluminum. 5. Carbon group. The carbon group is made of elements called tetrals, which refer to their ability to carry a charge of 4. Carbon group, or tetrals, have 4 valence electrons, diverse properties intermediate between those of metals and nonmetals, and the best known member is carbon, which commonly forms 4 bonds. 6. Nitrogen group, or pnictogens. They have 5 valence electrons, and diverse properties intermediate between those of metals and nonmetals. The best known member is nitrogen. The oxygen group, or chalcogens, have 6 valence electrons. 6 valence electrons. Diverse properties changing from non-metallic to metallic as you move down the family. The best known member is oxygen. 7. The halogen family. The halogen family is a group of reactive nonmetals. Halogens have 7 valence electrons, are reactive nonmetals. Melting points and boiling points increase with increasing atomic number, and have high electron affinities. They change state as it moves down the family, with fluorine and chlorine existing as gases at room temperature, while bromine. That thing is a liquid, and iodine is a solid. 8. The noble gases. Noble gases are a family of unreactive nonmetals. Examples include helium and argon. Argon. They're gone? Oh no. Noble gases, or inert gases, have 8 valence electrons, typically exist as monatomic gases, though these elements do rarely form compounds. Stable electron octet makes non-reactive, inert, under ordinary circumstances.